Hello, and welcome to tutorial number 21 of this beautiful year of 2020, where I'm going to kind of change things up a bit, and I will be creating a intro animation to the channel, to the YouTube channel that you're watching right now. And I'll be doing so, of course, in Grasshopper because it makes sense, and I'll just kind of take you on the journey together with me, trying to figure out how the heck do we make a animated splash screen for the intro of our future videos. So to start things off, maybe I don't even need Grasshopper. In the top view, I will set up a rectangle, some sort of a form in which some cool Grasshopper stuff is going to happen. I still have no idea what kind of. Well, we can fix that later. So I create a number 0.5 and I use offset. Well, that's pretty easy. We just measure the length of if you take any kind of a curve and you offset it outwards, it's going to have a larger length, right? But if you offset it inwards, it's going to have a shorter length. Duh. So we will be doing that trick. I will before we do that, I will just check out what kind of output we get here with a panel, or rather not with a panel, with a param viewer perhaps. Crap. Okay, so here you can see that in every branch there is only a single curve, and I want to have two curves in every branch. And then if we look at it from a more graphic view, you can see that each branches out into these two branches. So one contains an offset with -0.5 and the other one contains offset with +0.5, which sucks. We want to compare these two, meaning that they need to be in a single branch. To fix that, we will be using a tool that's called, and actually let me have it here. We will use a tool that's called Trim Tree. What this tool does, and if I just connect the offset to the tree input, it will start working. What this tool does is it merges these branches back to a single point, right? So if I were to check how this one looks like, you can see that these two branches were just merged into one branch, right? So now I will have two curves in each list. This one and this one belong to the same list, which means I can measure their length. So I get a bunch of, that's by the way not list length, that's curve length, keep that in mind. So I get, two values, and I always want to pick the curve that has the smaller value. So what I'm going to do is I'll just sort list. Sort list works in this way. If I have a panel and I have numbers like 55, 43, 297, 0, 1337, whatever. I have a list of numbers and I connect them to sort and I check out what kind of output I get from sort. You can see that it sorts them from smallest to highest value, right? So I can do the same thing with lengths. When I sort them, I will always have a smaller value at the top of my list. But the problem is that these are only numbers, right? They are not curves. How do we get curves? Well, that's why sort has a second input, which is values to sort together with the lengths. And those values are going to be our curves that come out from Trim Tree tool. All right. So now I have my sorted curves. There are still two curves in each branch, but now they're sorted, which means that if I always, using list length, which by default gives me, nope, not list length, list item. If I always grab the first item of the list, and this is exactly what it does by default, from the A output, I will always have the shortest curve for each branch, right? So now if I hide everything, and hide here, and hide here, also here, if I hide everything, and let's look at it in top view, you can see everything offsets very, very smoothly, perfectly. Perfect. Okay. So now we do have, and of course we have a full control over the gap and so on. So now back here, we do have this line here. So what we need to do is we need to loft between the top line and the top line and the top line, I guess, the new one that we've created. So I will just like we did merge loft here, I will also do merge. And for that, I need to figure out where this line is, where this line is, and where this line is. So let me just, yeah, there we go. Okay, that was easy. No, wait, no. It's the wrong one because this is already moved up. So it's not that one. It's rather, yeah, it's this one. So, okay, so this one goes into D1. And the offsetted and moved and offsetted version goes into D2. There's no D3. We loft. And we have our shape. So now you would be thinking, oh crap, we need to do the same thing for the bottom. Not really. The reason why I moved it by negative 0.4 and then moved it up by twice as much, right, was to have my whole form still centered around XY plane, right? So the XY plane is goes right through the middle of my form, which means that we can take these lofts that we have and we can mirror them. Mirror according to XY plane. So they will just be mirrored downwards, right? So that's the original loft, that's the mirrored loft. Original, mirrored. Easy. Okay, let's make a bunch of closed poly surfaces. So now I'm going to hide everything except first loft that we have, which is the ribbons, second loft, top chamfer, bottom loft, and the mirror output, which is the bottom chamfer. I will merge them into a single list, just like that. And I will use brep join. Brep join on them. Perfect. So now we have a bunch of joined up, separated breps, but they have openings, but that's very easy to fix. I will just use cap or cap holes. Cap holes on them, flatten them out, flatten out the cap output, create a custom preview, create a swatch, make it nice and blue, just like that. Go to top view and check out how it, how it looks. Nice. Okay, so we have that, and we will animate it, of course, later, but for now, this is what we have, and it seems to be working just fine. So now, let me actually save the document, LTH or tutorial 2020-21, save, file, save as tutorial 2020-21, save. Okay, so we have that. Back in perspective view, I'll disable the preview of this one and I'll just show. So to show everything that I have here, and I'll just delete, 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 delete. There we go. So right now, as I was building this, I already noticed that this will not work perfectly as it is, simply because, let me show you. If we have, let me ungroup this, and if we just use the L, letter L here, set one curve, and then we look at the preview output here. See how messed up it got immediately? That is because under surface split, it will give me, two surfaces, of course, the letter L and everything else. That's not the letter L. That's fine. But then when I get the wires, I get the boundary here, and I also get the L boundary. And the problem that happens is when I join them up, while letter L is fine, the other one, how can I show you? Oh, I know. Sorry, list item up with is a surface with a hole in it, right? One of them. When we try to join them up into a single closed boundary, it fails because the surface has a hole in it, right? So we end up getting two closed polylines for this surface here. We move them up, move them, or rather we move them down, move them up, blah, blah, blah. And then we loft them, right? And when we loft them, it doesn't understand that it needs to loft here and here, right? So it's a whole problem, which we can fix in two ways. We can either say separate, separate the curves and loft them separately and kind of work around with that. But I don't really want to do that. Instead, I will make sure that everything here doesn't have a hole, like every, and like this, right? And I will reference in these three lines here, set multiple curves, and then I look at the custom preview, and it's working perfectly, right? That's because this is a single surface, right? This is a single surface, and this is a single surface without any holes whatsoever, right? List item, right? 1, 2, 3, no holes. Okay, so I need to go through, in Rhino, I need to go through it all and kind of make sure that there are no holes. I always wanted to do this throughout the tutorial, just to make it nice and kind of connected properly. And we will just see, ooh, the letter U will be very awkward to work with. We will see if we can, if this will work. Just like that, and then this one maybe does something like that. For now, I'm just messing around. Something like that, and so everything needs to connect and not make a hole. If we get a hole, we will definitely notice. Maybe you're at 45-degree angle. Is there a way to snap to 45 degrees? Hello, Smart Track? Do you have, oh, come on, stop, no. Oh my God, OBS, stop. Set ortho angle, there we go. Ortho angle 45, enter. So now I believe I will be able to do without Smart Track on, I will be able to turn on ortho and then snap to 45 degrees. With snapping turned off, there we go. Okay, that seems to do the trick. So maybe this one is also, that's a bad one. No near snap, no point snap, no midpoint snap. No, we don't care. No vertex snap, okay. So let's go through it. Actually, near snap needs to be turned on. There we go. Maybe this one just goes through. This one does that. So you have that. This one is just maybe doing something like this. Just like that. Like that. That's good, that's good. That's good. And then you will do maybe this. The start of the definition, set multiple curves. Okay. Check out how it looks like. And it's perfect. Okay, so now we know that it works, and even the sharp offset here works. So I will speed up the video for a bit and kind of go through it all, just creating these panels. So just give me a second. Okay, super. We are back. So, I was just taking care of the letter R because that one took a while, but yeah, I'm pretty happy with the pattern that we ended up with. And I didn't want to do any, kind of hexagonal patterns or so on, but you can have a hexagon pattern, you can have a rectilinear pattern, doesn't matter. I will be using this one. So now I want to, well, first of all, yeah, and that attractor point should be influencing these elements in some way. I still don't know in which way, but we'll figure it out. So first of all, attractor point. I could just create a point right here in Rhino and just use it. But instead, I will be trying to do that in Grasshopper. So let's say, what would be a cool one? Perhaps we have, okay, let me actually draw out, create a new layer. I'll call this attractor curve, not point, curve. Layer, I'll make this red. And in that layer, I'll just draw something like, I don't know, a curve like that. And then CRV, I will reference in that curve, set one curve, just like so, and I'll just drag it to the end of my current definition. So I have a curve referenced. And what I want to be able to do is I want to be able to create a point on this curve, right? A point that would follow this curve and just move it with a single slider. So I can do that by using evaluate curve component. Or was it evaluate length? Evaluate, yeah, there's both. I'll just use evaluate curve, and I'll say parameter is always in between 0 and 1, so 0.500, something like that for a parameter. Remember when I said that it's always between 0 and 1? I lied. It's between 0 and 1 only when you right-click on the curve input right here and choose to reparameterize. Then it is always between 0 and 1. And if I was to, let me make this a bit more transparent, just like that. If I were to move this point, you can see that it kind of, by moving the slider, I can move this point from, you know, along this curve. So I'm basically constructing this kind of attractor point path for my animation. Okay, I have that going on. And now, how does this attractor point actually work? So let me get rid of the custom preview for now, because I don't need it. For this cap, I will just create a brep component right here, and I'll just call this bunch scale down. Let's start by scaling them down, or do this going to be scaling involved? Scale, right? When dealing with attractor points, you always geometry to this geometry to this geometry, and to do that, I will just use. Do we use pull? Let's try pull. I don't want to do that. Instead, okay, we will be using pull, but before I will get the center point of each of these breps. And to do that, I simply measure the volume of each of these breps. And that takes way too long, so I will not be doing that. Instead, I will be creating a bounding box around them, around each of these, and I will be evaluate box. I will be evaluating the bounding box at 0.5, 0.5, 0.5. That also gives me a center point. And as you can see, this is like 10 times faster. Okay, so I have my points, center points here, and let me just point to show you. Some of them are weird, you know, for this L shape, the center point is here because the bounding box is like that, but most of them are okay. And we'll see if this will work. Most of it is okay. If it does these guys, the smaller or rather the larger they will become, right? So I will be scaling. Okay, I will be scaling these breps for sure, like that, and I will be scaling them according to their center points. Oh man, so what happens if we use this? It scales in quite a shitty way. Okay, fine, I'll measure the freaking volume. Connect brep to volume, get the center points, delete those, and just connect the volume to here. Okay, so now you can see they're scaling a bit nicer. But since volume is so heavy, I will be creating a data dam right here, which will not let information through as long as I don't press the play button. The red for the data dam. Press play, calculates, does its thing. Okay, so scaling is there, and now for the factors. So the closer they are, the larger they become. So they're when the point is closest, they will become 1, strength of 1, or rather factor 1, and when my point here and these points here, so I have my distances, right? And I need to remap my distances to be in between 0 and 1, or rather not 0 and 1, but something very close to 0. If we give it 0 like this, it's going to... it's not freaking out, but it should freak out. So we're not gonna do that. For remap to also work, for remap numbers to work, we need source domain, and that's basically what's the smallest value and what's the largest value. To do that, I will just get bounds of the distances, and then you can see that, you know, the smallest distance that I have is 5.73, and the largest one is 1.158 millimeters. So that's my source domain, and target domain is going to be between 0 and 1. Let's just see how it works. Now it's freaking out. Okay, so now technically, if I move this point, okay, they react. It's very them. Perhaps it's going to make it faster. Simple mesh. Simple mesh immediately crashes, and mesh brep. Speed settings. Ooh, it's a lot of polygons there, but perhaps it's fine. Volume checking is much faster though. So we're not using a brep, rather we're using a mesh, and let's see. Oh, now it's so much faster, but it's a little bit jiggly. Or maybe not, maybe I'm mistaken. Let's see from afar and slowly move this. I don't really like how it works, so I will not be using bounds, but I'll say, okay, we have the distance. Everything that is larger than it's going to start freaking out. Just kind of removes a few. It's from here. That's because of the remap. That's fine. Oh, let's think. Okay, I want the point to have an influence radius. That is not how you do it. 5. There we go. Oof. There we go. So I want my attractor point to have an influence radius and another one, right? So everything that is outside, and this is my attractor point, everything that is outside of my of the influence radius is scaled down to 0. Everything that is in between, or rather everything that is inside, is scaled to 1, and everything that is in between goes from 1 to 0. Okay, so I need 2 radii. Okay, let's first figure out the radii. And to do that, I will have a point here. And just to make it clear, let me just delete, and we will be redoing it again. I will keep the scale though. So evaluation, I will create a circle, CNR, like ring. What's the smallest radius? I will say 0. Or not 0, let's do 20. You know, full one, the scale of 1. Then everything that is outside of, or let's say here with 60, is going to be deleted, right? It's going to be deleted. And then everything that's in between is going to be between 0 and 1. So first of all, I will measure the distance. Where were we? Distance between this point right here and all of the center points here. Okay, we have a bunch of distance, and these circles are just for show, so I'll just have them here. And I will ask, is the distance larger? You know, the distance between this point and these center points, is the distance larger than 20? And if it is, then, or rather, is it larger than 60? Like that. And if it is, cull. Remove. Let me get rid of center points further out than distance of 20, or of 60, sorry. So that does it, but it does it the opposite, other way around. So I will just right click on the P input of my cull and choose to invert. You know, so true becomes false, false becomes true. Okay, so we end up with these points here. And then that is the thing that we're going to be dealing with. Or not, come on. I assume if I were to, where's the slider? If I assume if I were to move the slider, yeah. So it does its thing, that's great, but it's not doing it in an elegant way, so to say. But perhaps we can work it out. Okay, so here we are removing. Here we are removing everything that is outside of our influence radius. That's super. Okay, and we end up with a bunch of meshes that are inside of our circle. So I will just get the center points of the meshes again by just measuring the volume of them. Volume, center point. And I will repeat the same thing, right? So I have the center point here, and I will measure the distance again between what's left and the point here. So I get another set of distances, this time a smaller list. And this time I will ask, is it larger than 20? Because I want to separate the list of these leftover elements into two lists. So I will not be using cull, but rather I'll be using dispatch. What dispatch does is basically separates the... I'll just use a mesh node here. You can see that I get all of these meshes here, and I get all of the inner ones here. So we will not be touching the inner ones. The inner ones are fine as they are. We will be just working with the outer ones, these guys. So these will be scaled And they will be, again, they will be scaled according to their center point. Volumetric centroids, like that. And the factor of scaling is going to be according to, again, the distance, right? So we measure the distance between our attractor point, which is here, and our center points here, just like that. And then we remap. This time we will do it. We remap the distances according to their bounds, just like that, to a target domain. And the target domain, I will just create a panel for that because it's easiest for me. The target domain is going to be, okay, the smallest distance will need to have scaling factor of 1, and the largest distance, so I write 1, 2, and the largest distance is going to have scaling factor of something very close to 0, 0.001, something like that. And it's not happy. Why is it not happy? Data conversion failed from text to number. If that happens, that means I have, that means I've plugged it into the wrong node. It needs to go into remap, and then remap goes into scale, right? Because it now remaps all of the distances to scaling factor values that I want, like that. Okay, let me start hiding things so that you can see what's gonna happen. And where's the slider? Let me move the slider and you can see, this stuff appearing. Just like that. Okay, that's good. So now, and we can play around with these values as well. Out of existence. So I will choose, I'll do the same thing, right? I will rotate in 3D, and I will choose to rotate the scaled geometry as well around the angle center point, around the center point, their center point. And the axis of rotation should be not Z, but something nicer. So let's say, can we just add up 2 vectors? Or rather, I'll just write 0, comma, is it comma? I don't remember. Yes. So I'll just write 1, 1, 0. Or not, / 1, 1, 0, enter. There we go. So it means it adds a, exactly like that, right? It just adds a vector there. And then I have an angle for rotation, right? So I'll change this to degrees so that it's understandable what we're going to do. I still have this distance measuring, right? So what I want to for this to happen is when they are very close to the center point, to the attractor point, they are not rotating. But when they are far away, they're rotating 90 degrees, right? So I will create another remap numbers. I'll reuse the distance values here. My source domain is going to be reused as well from the bounds, but this time the target is going to be, again, in a panel, somewhere between 1 and I'm thinking the closer we are to a attractor point, the less rotation there is, right? So when we're close, so that's the first number, the smallest distances, right? When we're close, rotation is 0. But when we are far, rotation is 90. Okay, like that. Plug that into angles, and there we have it. Okay, let's see how it looks like. Is it me, or are they... Wait. They are rotating. Let's see it in perspective view. With custom preview. Or let's keep it pink, that's fine. What is this? Oh, that's the dispatched meshes. Okay, those also get a custom preview. That's the ones that are not affected by the attractor because they're too close to the attractor. Okay, let's see. Larger radius, perhaps? Something like that. And we go. So they are rotating, but what if we do 130 degrees? A little bit more. Okay. It's doing something. Okay. I think that's A-okay. And then we just need to adjust the curves, the curve, and we will call it a day, right? Of course, if you want to set it up nicely, you just go to top view, or rather, you go to top view, and then can we change this to perspective in some way? Or rather, let's change this to Arctic view. Like that, and then where is it? You animate, you right click on the parameter of this like movement for the curve, and you choose to animate, and then you can kind of set everything up as you want. I will not be doing that. I will just be simply checking out. And that's kind of nice. Okay, that is good. So now we are done with this tutorial. Of course, as per usual, I'll be speeding up the remainder of the video to show the process of how I end up with, with my final animation. But yeah, thanks for watching, and I will see you on Sunday. Subscribe.